It's time.
Greetings. If everyone could take their seat, please, and get ready for an awesome discussion about adaptive DNS, which is no doubt the most interesting, best topic at the entire IETF this week. Pardon? I am. Oh, I was hearing myself. So this is ADD. So if you can take your seats, please, so we can get started. Still more? More. All right. Take your seats so we can get started with ADD, the best working group at the IETF. With the best AD at the IETF. Welcome to ADD. This is an IETF meeting, so please be aware of the note well. It does apply. If you'd like it explained, I'm also the chair of the IETF Trust, and I would love to talk for IP rights issues for hours with you. And if you want to avoid that, read it yourself and comply. I'm Glenn Dean. I work for Comcast NBC Universal. I'm one of the co-chairs, and my co-chair is?
Hi, Tail.
He's so cool, it only has one name. And of course, we have the best area director in the entire IETF, Eric. So today we have a sort of flipped agenda. Originally, we were going to have Tommy come and talk to us about the draft they have active right now, and it's been discussed on the list. But because we have a conflict with several people that are at the other, I guess the Scone CD or whatever it is session, we flip those and we'll do, as I sent on the email earlier this morning, that's going to be the second half, which is going to be this afternoon. So this morning, we're going to go through the regular agenda, and then we're going to dive right into the discussion about architecture and directions this group wants to take in terms of architecture. So with that said, you said we've got a scribe set up?
Yes, Liman is going to be our scribe. Thank you very much, sir.
So here's the agenda. Any bashing people want to do? Anything? Take it off, add it on. 1, 2. Agenda bash complete. So welcome for the chairs. Oh, is there a problem? Oh, it's Tiru. You're supposed to manage YouTube.
Thiru Nokia, I wanted to know the progress on the split horizon draft. I think we have addressed all the working group last call comments. So,
well, in fact, when we get there, we were going to announce that we were about to push the button and move it on because we were going to call the working group last call complete, and we're going to move it on to the area director to take the next steps. But now I've got I spoilered it, dude. That was a big announcement. You stole it. Anyhow, and that's the main thing. The main comments we wanted to make, and the reason we're going to talk about the architectural stuff today, is we did have a couple drafts that were up for a working group adoption. They received a lot of support for adoption, but they also received a lot of comments back that they did not like the security models and security impacts in the way they were doing things. So we've decided to take a step back and not focus on the drafts in question, or yes or no, is that how we want to go? And instead, we're going to talk about sort of where we want to go architecturally in terms of security frameworks. And for those who've been with ADD for a while, we had a very similar conversation back in the early stages of ADD when we discussed, should we allow DHCP RA environments to be mechanisms for assigning and allocating or communicating your resolver options for DOE. And after a lot of debate, including some people said, well, we absolutely needed an authenticated DHCP option created and architected for the IETF. And a lot of other people stood up and said, well, we've tried that several times and it's failed each time because it's a very hard and intractable problem. We eventually came to an agreement on how to do it, and we successfully put out and published back in November the specification for how to do discovery of adaptive DNS resolvers through DHCP RA environments. And so it was a good example that, with discussion of the problem, we were able to come to a architectural design point that people were happy with. The hope is, as we discuss this, the world and the operational environments that are driving us for these questions around the next approaches for certificates and delegation, that we can find maybe a common path forward in this world too, and that these drafts that came up, and one of them took it out, so there's really one left with that in it, that we can find a path forward that we can do these kinds of things. The other option, by the way, is we may decide as a working group that there isn't a path forward and that this isn't work area that we can do or want to do. That's a perfectly valid outcome that the working groups can decide. The role of the chairs, we've talked about it a lot, is that we are here to guide the process for you, the working group, to talk through the issues, to make the decisions on what you want to do and what directions you want to go. This is not a top-down organization. This is a bottom-up organization. So today we're going to talk about the why, what's the motivation for doing these things. Tiru has very generously agreed to write up a presentation that we're going to show and try to understand for the group the motivations behind why this question is even being discussed. And they're rooted very much to the fact that we have a large amount of deployed infrastructure around the world where users daily are working in a space where they today cannot make easy use of adaptive DNS discovery, and they can't necessarily make use in some cases of DOE and other encrypted solutions. And so there's a real sort of operational need. If we go back to the core of the IETF, running code is important as a way to decide how we do things. You can see all these operational deployments as a sort of example of running code that we have to talk about and address. So that's the setup. Tail, do you want to make any comments?
Well, I was just going to mention also that because of some conflicts that happened this morning with other meetings against this one, we anticipate also revisiting this afternoon with a short summary and then additional discussion with people that can be in the room then. So.
Yeah. Tira, we hadn't told you yet, but we're going to have you do a short recap this afternoon of the stuff you're about to show now. So thank you for doing that, even though we volunteered you for it. Anyhow, with that, does anybody have any questions or discussions they want to have? The next step is we're going to have Tira show some slides on the motivations behind how we've come to ask this question about architecture. So does anybody from the queue or anything before we move on? Okay. Well, thank you. Tiru, let me bring up your slides. And we got a clicker right here for you.
Good morning, everyone. I'm Thiru. I will talk about the need for hosting encrypted DNS servers on CPEs. It could be CPEs or managed CPEs. It could be used in home networks, enterprise networks, or any other deployment. Just setting the context that we already have DNR and DDR specifications out. They pretty much make it easy for endpoints to discover and use encrypted resolvers provided by mobile networks and ISPs. That solves one leg of the problem, right? Instead of going to a pre-configured resolver. The other challenge is home network users have been using CPEs all along. What was the reason for using that? If you see, it's been used for several purposes, especially with the evolution of managed CPEs. CPEs could be managed by the ISP, managed by the router manufacturer, or it could be managed by the network security vendor who is hosting network security services for protecting the home router. There's several reasons why ACPs are managed. One main reason that I would say, and I have been working on, is to improve security of the home network. One primary purpose was to filter all the malicious domains. We had techniques for anomaly detection. One of the primary advantages that I could see with the solution that we had was protecting IoT devices. Manufacturer user description is just one specification which defines for IoT devices, they have a specific intent, so they would visit specific domains, unlike a traditional general purpose endpoint. So we could define profiles where the manufacturer would give us the domains that an IoT device would visit. So it would reduce the attack vectors that would be possible to an IoT device. And even if an IoT device visits any domains beyond which it is intended to visit, we would detect and block and notify the home administrator. Beyond that, there are several other advantages, like it improves performance, that all the DNS resolution, or it would cause aggregation by the home router itself, caching would be done, and it also helps provide local services. When we started deploying network security services on home routers, there's a lot of work that happened in several other organizations to secure these home routers, because you can't run network security services if you're running on a platform which is insecure, right? So these home routers, if you see, have been upgraded in the last 5 years, I would say, to have the best security practices similar to any enterprise router. Now, coming back to the challenges that we are facing after deploying these network security services was, hey, we could host DNS encrypted DNS servers on the home router, but then how would we provision these CPEs with certificates provided by a CA, and how would we work with the CAs to get the CA signed certificates? And managed CPEs do ease the burden, but the scale is a problem. For instance, in my previous organizations, we were shipping around 6 to 7 million home routers, and we had to manage so many certificates. I'm pretty sure there are several other competitors who are also shipping on millions of routers, and they would also have to manage such a large scale of certificates. Yeah. Quickly talking about what's happening in the modern managed CPE, we already have several flavors of open DNS resolvers or DNS forwarders that are optimized to run on home routers. They could run in containers, for instance, Docker for isolation purposes. Network security devices are already running on secure home routers, and it's offered by several security vendors, McAfee, SAM, Trend Micro, several others. I don't list all of them, but you can imagine there are like at least 10 to 15 of them who already offer these kind of services. And millions of secure CPs are already deployed today. Now, what happened as part of the transition for these CPs to host network security services is we started working on the requirements and then the functionality that would be available on these managed CPEs. I'm just listing few of them. I'll give references to where all this work happened. All this work has happened as part of PRPL Foundation, which is an open collaborative body for developing secure platforms for home routers and embedded devices. Some of these features, you might have seen all of this in traditional enterprise routers, that it would have a patch management and update policy without user intervention, secure transport, certificate management, and secure firmware update and secure device management. The other ones are pretty straightforward in the sense vulnerability management, exploit mitigation, runtime integrity to check if the platform is compromised or not, and then microservices and containers for sandboxing various network services. Lots of work has happened in PRPL Foundation in the last 6 to 7 years, and we were part of that foundation to basically harden OpenWRT, and now that's being shipped and it's in production. There were some questions during the working group that, hey, you already have WPA3, it's using quantum resistant crypto. Why do you worry about, why can't you just stick with DNS over clear text, right? Yes, WPA3 does offer security, but the challenge is there could still be multiple network devices between the endpoint and the network entity which is hosting the DNS forwarder, and you would want to make sure only the endpoint and the DNS forwarder can look into the requests and responses. For instance, in case of a mesh deployment, you would have multiple mesh routers, and you would typically encrypted DNS forwarder could be deployed on a mesh gateway, and you would only want to see the mesh gateway see that. The other challenge is clients may not know what's the underlying Wi-Fi you're using, and the other challenge is the DNS resolver may or may not be co-located with the WPS server, right? So with that in mind, right, I mean, when I started building that product long time back, we were looking into both the mechanisms on which discovery mechanism would work for these CPEs. GDR scope is restricted to public IP addresses, as we all know. And one challenge that we see is that CAs are not supporting IP address-based validation. If you had to go talk to, let's say, use Let's Encrypt or some other CA, they don't do the ACME validation based on IP address, and it give you a certificate based on IP address. And the other challenge was whenever IPv6 prefix changes, your certificate has to change again. So there's no way that we could do any deployment with GDR as such. DNR was our plan that we could do something with DNR. One possible solution that we had opted was, hey, let's provision each CPE with a unique subdomain. For instance, cpe1.isp1.com or cpe1.networksecurityvendor1.com or something like that. And we would talk to the ISCAs and get each of these home routers provisioned with a certificate, which is unique to each home network. That pretty much solved the problem for us, but it went through a lot of discussions with several CAs because they were reluctant to give us millions of subdomains and millions of certificates. So for instance, when we tried Let's Encrypt, they realized we were bombarding them with more than millions of requests, and they just started rejecting. And when we had a call, they felt like they were subjected to a DDoS attack. Right. So it solved an interesting problem that that I think everybody would have faced today, that we always access our home router with HTTP access, right? Your local IP address that your router manufacturer would give. But this changed the game, that we would give the home router a HTTPS access because we have a subdomain assigned to it. And now we could log into the domain portal using router portal using HTTPS. So that was probably a major win that came as part of as a byproduct of basically hosting certificates on the home router and then provisioning a unique subdomain. Yeah. So the problems that we faced right at that time when we started deploying this was dependency on the CA, especially to host millions of certificates on millions of CPEs. And then the whole cycle of refreshing this, because usually certificates have a typical lifetime of 60 days, and you would have to keep refreshing them. By default, CAs thought this is a DDoS attack unless you have a business agreement with them and you have an arrangement that, hey, this is not a DDoS and we are a subscriber. They don't give you those many number of certs. There's a lot of work happening in other working groups with regard to the scale problem, even with CDNs, like star certificates, where you have a pub/sub mechanism to basically renew certificates for your downstream CDNs. But the scale of downstream CDNs seems to be much lower than router deployment, which would scale into millions. There were, in addition to what we have already done and the challenges that we face, probably still facing, right? Managing these sets, we thought we were looking for other potential ways of simplifying this dependency on the CA. There are disadvantages and advantages of all the approaches. For instance, we tried the TLS delegate credentials. It has an advantage that it would completely remove the dependency on the CA. CA would just give one set, and delegated credentials would be assigned by the entity managing these home routers back to each of the CPE, which is like, you still have unique public-private key pairs on each of the home router, but they would be signed by the entity who is managing these home routers. The only challenge with that mechanism was that none of the clients were supporting this. And the other challenge was that even we wouldn't give an unique subdomain to each home router, so you wouldn't get a HTTPS access to the home router. The other one was name constraints, which is like a sub CA, but none of the CAs support that because of various regulatory and other reasons. And the CA browser form basically does not encourage that use being supported, and it requires frequent auditing. So none of the CAs support that. So this is like the current state of the art that I see, that there are 3 to 4 solutions. We have deployed one solution which required a lot of traction with the CAs. The other ones, among the other ones, the subsets was probably a one that we had presented a draft, but there was a lot of questions back and forth with regard to the deployability of this even on home routers, and the need for doing this on home routers when we could do this just with the ISPs encrypted resolvers. So that's where I think we got struck, and I think I'm glad that the chairs have asked us to take a step back so the working group realizes there is a problem and we have solved it in a particular way. It would help us to see, like, are we going to solve this problem in a conventional way of managing these certs by ourselves? Are we going to do something else to make our life easier?
Are you ready for some questions here? Yeah. Michael, we can start the queue.
Michael Richardson, I just wanted to reiterate what you said about name constraints. In 2018, 2019, I was involved in a project to put certificates in devices, and we had slightly different reasons than DNS issues. And I actually spent at least 3 months reaching out and talking to CAs, asking them whatever happened to that enterprise certificate stuff that we used to be able to get. Okay. And a bunch of them went, what? We ever did that? What? Well, that would be a good business model. Okay. Like, and you know, so I was talking about like, and so the things that came out, it used to be like $20,000 a year or something like that. And that wasn't crazy for the entity that I was in. Okay. But what we discovered is this was a product that some of them remembered selling. They couldn't remember why they stopped selling it. Okay. Because it seemed like a good deal. But eventually I understood what you just said, and it's forum, not forum, but just to make clear, it's a C browser forum, CAB forum. And the issue is that the CAs have to implement certain policies on what they do. And when they issue that subordinate CA certificate, they have to make sure that you implement all those policies. And that's where all the money and the auditing, and suddenly $20,000 seems like a loss to them when they do that. And then your impact of doing that. So effectively, the only way that they support subordinate CAs is if they run the CA for you, because that's the only way they can make the auditing cheap, which is they run the software. Okay. At which point I asked, so how much for each of my IoT devices will each certificate cost? Anyone want to get order of magnitude guess?
$1,000.
$495 each. I think I was getting the quantity discount, right? Because I was like, are you sure that's the quantity one or the quantity 1,000? I'm going to be buying thousands of these. Are you sure that's the number? You don't mean $4.95. Because that was like, whoa, on my, kind of thing. So I just want to emphasize that, the stuff that many of us in the standards community, in the X500, 509, that stuff that we used to imagine would happen, right? It did happen. It did happen for a while, and then it stopped. And it stopped for legal and other reasons. And so a lot of people on the list said, just do this, just do this, just do this. And the technology is sound. The legal and business case is not. So I just want to emphasize that over and over again, because there's lots of people out there, again, academics, who think this or there. And I was shocked, like, oh, but this was really sad because I really wanted to use this. So just want to say that.
Yeah, thanks, Michael. I mean, I also spoke to several CAs, at least 5 or 6 of them. I was at least looking for 1 or 2 to support this, right? So that we don't have a dependency on one CA, but I couldn't find even a single CA who was willing to do this at a rate that would be applicable for us. Thanks.
Ralph Akamai, thanks a lot for doing this. And I mean, I definitely want to have the CPE kind of being able to terminate a secure connections. And I definitely see that there is a kind of financial problem there. I mean, there's this stuff out called TLSA that we actually put in the DNS, but it potentially could increase a kind of circular dependency. But if we could sign it with DNSSEC, I mean, having something that doesn't rely on this is probably a better way forward.
Yeah, I mean, if DANE could be supported by browsers, right? I mean, that's great for us. I mean, even if they could conditionally support just for this and not for the other purposes also, it's still great. But yeah.
Ben, please remote.
Hi. So yeah, I just wanted to first try to understand, like, did you try to pay for certificates and they said we won't take your money, or was it that you just couldn't, like, there was no pricing model that worked for this?
At the time we did this, we are paying.
Okay, so you were able to do this, and you were able to deploy this and pay for the certificates, and the problem was just that it was too expensive in the end.
Too expensive and too much dependency on the CA to manage all this. When the SLAs were like, especially when we were doing the refresh, right? The time to give new certs and all, the time was quite unpredictable. We had constant interactions with them, and it was felt like the time is quite unpredictable from few milliseconds to minutes together when we have to keep asking and refreshing those millions of certs.
Okay, thanks. That's helpful. To the chairs, I want to ask, should we like dive into the general architecture discussion, or should we focus on the slides for this queue?
So I think right now, Ben, making sure that everybody sort of gets up to speed on the problem scope and actually what is driving this is maybe phase one. And then then later on, and maybe that will be later in the afternoon session, we will get into the next phase of it, of like, well, what do you want to do about it? But I think it's important that everybody in the room or in the group really feels comfortable that they understand the issue and the framing of it properly. Does that make sense?
Yeah. In that case, I'll just briefly say, you mentioned the presence of entities between the client and the CPE as an example of why you might need encrypted DNS protocols. But any entity between the client and the CPE can also replace any of the information that we are using to bootstrap that encrypted DNS connection. So they can, for example, replace the DNR extension in your DHCP packets with a DNR extension that just delete it so that you'd use unencrypted DNS, or point it to an encrypted DNS resolver that they control. So I think it's not enough to build some sort of technical thing that can be used. We need some more serious threat modeling here.
Yeah, I mean, it would have. I was always assuming that if it makes itself more of an active attacker, then it would be pretty easy for us to detect that than if it was a passive attacker.
Okay, but if it's a passive attacker, then DDR, opportunistic DDR, already covers you, because opportunistic DDR lets you do the encrypted protocol upgrade without any of these certificate headaches.
Right. When I was referring to the passive attacker, there was a discussion in the working group that why do you even have to run encrypted forwarders on the home routers, and you could just run DNS over 53 because you're using
Right.
WPA3, right? So that was just to answer that question. I was referring to a case where, hey, you have multiple devices and you want to have end-to-end encryption rather than just relying on WPA3.
Sure. So this is my point here is that there's opportunistic encryption is a lot easier to accomplish than authenticated encryption here. And if we want to get to authenticated encryption, I think we need to convince ourselves that we are actually accomplishing that and not just putting a lot of sugarcoating on top of opportunistic encryption.
Right.
Thank you. Ray?
Yeah. Hi, Ray Bellis, ISC. Are you familiar with RFC 5625 DNS proxy implementation guidelines?
I think I have read it, but I don't.
I would urge you to read it and read it and then read it again, because all of this is completely moot if you can't do DNS properly. And I wrote that RFC some 15 years ago, enumerating numerous problems with DNS proxies within CPE, and I've no reason to believe anything has improved much since. Yeah, CPE are lousy at doing DNS, and adding this on top is just going to break the internet. Not many things are using DNS. DNS mask is not. Yeah. There are some CP out there with good DNS implementations, but there are billions out there with lousy DNS implementations. And as Lorenzo says, they have no update model. Thank you.
Eric, please, remote.
Hello. I think I'm with what Ben was saying of trying to do authenticated encryption using the global PKICs against something that's a home CPE device doesn't really make sense. It's unclear that what properties you're getting there versus some other alternatives. There's a something similar to the HTTPS for local domains that Martin Thompson put together a few years back, but never a draft on. I think I last looked at this after one of the previous IETFs, would provide the same security or better security properties for this ADD use case, but actually might have better properties, but keeps everything local to the home, so it doesn't bring any of the scale of privacy issues into play. But it has the downside that you now need to kind of build up this infrastructure because it's outside of the scope of kind of introduces a dependency outside of what ADD can solve.
Yeah, I don't think Martin's draft has progressed and it's expired currently, so I don't see any deployments of that.
Ralph Weber, in response to Ben, I mean, opportunistic upgrade would be great if it worked, but unfortunately it doesn't. I mean, at least the current stuff that is out there that actually works with DDR, some of the time works with opportunistic, some of the time doesn't. It's just not reliable.
And I thought many clients don't support opportunistic or enable it at this point of time.
So I've been to a lot of IETFs, as many of you have as well. And I know some of us read the drafts ahead of time. Some of us don't read the drafts ahead of time. I got to imagine there's still people in this audience that are starting to glean the understanding of this problem space. My question to you is, are you getting the problem? Like, have we captured it? Has Tiru explained it to you? Do you have questions that you would like to have clarified? And I know that getting up to the microphone in IETF is really scary. It's extra scary because DNS people are terrible. There's people here who've been doing DNS forever, and they know every little tiny little sub-qualified bit. I mean, it's crazy. But this is an important thing, and this is a discussion for the ADD working group, which is you guys, to weigh through and decide. And ultimately, we as chairs are going to try to figure out, is there consensus amongst the people in ADD of how they want to approach this? There's no right way, there's no wrong way, there's the ADD way. So, are people in the audience, are you guys comfortable online, in the room? Do you have more questions? Do you want more clarification before we start talking about how do you tackle the problem space? Now's the time to have that sort of question. I see we have one join the queue.
Oh yeah, Andrew.
Actually, we have one more before.
Oh, okay, right. Puneet. But people who work for the IETF trust are terrible or something.
But
I'm not going to sit here and take you saying DNS people are terrible, man.
Well, I was trying to make them less afraid of you. But I will say that to defend the IETF trust, we are volunteers. We don't get paid, so you get what you pay for.
Puneet, you're remote, right? Yeah, go ahead.
Yeah, so I think taking Glenn on his request, I think a question both for Tiru and I think for the other presenters is, someone, I think it was Ralph who said opportunistic DDR doesn't work, and Tiru also said it's not necessarily implemented. So one question I have is, what devices / applications are we talking about on the client side here, which are in scope for the improved protocols? Because seems to me like those ones are the ones which are going to see new software deployed anyways.
If I get the question correctly, Puneet, we're just referring to typical endpoints, right? Operating systems and browsers who are doing these discovery mechanisms.
So I think the thing I want to, maybe it's not to be answered immediately, but like these are the things which these pieces of software are the one which can implement DDR or any other protocol, right? So I'm not sure I'm getting the point about DDR is not implemented or not working for those client devices.
I think he said DDR works, but not in the opportunistic mode.
Okay, I'll
And
follow.
my understanding was at least one implementation that I saw never supported the opportunistic mode the last time I checked.
Sure, but one out of many. So I think I'm trying to understand, is DDR not working because the protocol has issues, or is it just because the clients haven't gotten around to implementing it?
So there are two challenges with DDR. One is that we haven't seen the opportunistic implementation. The other challenge is, especially with these CPEs using private IP addresses, it's not possible that you could use the authenticated mode of it, right? So it's just going to be opportunistic. We could never make the authenticated part of DDR work. So opportunistic could work, provided there is a client support for it.
Okay, thanks.
Andrew.
Hi, Andrew Campling. If I reinterpret the question that Glenn asked into, is this a problem that needs to be solved? Then I think it is. I think if I cast my mind back to when we started on the journey with the ADD work, there was a sort of a realization part way through that actually this architecture with a DNS forwarder on a private IP address is the sort of dominant solution in most of the world outside of the US. And it seems to me it's a good thing that we deliver a solution that works properly, so end to end in that environment. And that was precisely why DNR was was specified in the first place, because of the limitations with DDR not working with a private IP address and DNS forwarders. So I think we do need to solve this problem.
Thank you. That's you, Mr. Houston. Are you local or remote? Oh, there he is. Yep.
Jeff Houston, I think on the previous slide you mentioned RFC 8739 as being the foundation here, yes? Somewhere there's STAR certificates, is that right?
Yeah.
Yeah, STAR. I notice you can't revoke a STAR certificate. I notice if you lose your key, you just have to tolerate the badness of whatever scale the badness might be until the damn thing expires. You know, let's encrypt it's 90 days. God knows what these lifetimes are. Are you seriously proposing a framework around CA certificates where as soon as you stuff it up, there's no going back? You just have to don your asbestos undies and just live with this stuff burning in front of you until the thing expires. That's the theory, right?
Right. So
right, great. That's all I really wanted to understand.
Yeah, makes sense, right? So what I was trying to say was that, right, with a fully managed cert like what we have done today, we could, in case if we see that the managed CP has gone wrong, we could just immediately revoke the certificate. But rest of all the mechanisms, including delegated credentials or STAR, has a lifetime. There is no way to at least in STAR, I believe there is a way to revoke. Delegated credentials have a lifetime of 7 days. We can't revoke that, right?
So badness needs to be a slow burn.
Right.
It takes more than a week.
Yes. So that's the reason
I like those kinds of badnesses. I just wish they existed in the real world. Yeah, it is a problem once you walk into this space, that revocation is this soft underbelly of the entire sort of PKI sort of place. And doing instant revocation has its own overhead, which in STAR they simply said, no, we're just not going to touch that. It is what it is. And if your key is compromised, badness is going to happen and you can't stop it. seems a bit weak for this kind of work is where I was leading to.
Yeah, I'm not advocating star, right, as such. I was just saying that these are all the mechanisms that are there in IETF so far.
But if you don't advocate star and you're doing certificates, how do you handle revocation?
We are not doing star. Currently,
Oh,
we are
but
using
if you're
a,
doing certificates, how do you handle this problem?
we are using revocation, the typical revocation mechanism. We don't
The
use,
one that gets updated once a week.
we have 60 days, right?
Oh, 60.
Yeah, 60 days. And we have the full flexibility that the operator of the device can revoke the cert at any point of time. We are not using star certificates.
But it's checking the revocation that's the issue, not the fact that the CA revokes it. You can revoke it anytime.
All the clients do check for revocation today.
All the time.
All the time. Yeah, every time they establish a new connection.
If I can step in here. So,
If you could.
Jeff, you're asking good questions, but I think they're about a very specific deployed solution that he's taking lessons from. And we're trying to talk about the higher level abstract. Is this an approach the ADD
And
wants to take or not?
Where I was heading was that in all of our deployments of PKI certificate systems, revocation is a real issue. Because if you're constantly doing, here's a certificate, I need to check its status, then that's a huge amount of traffic that goes to wherever that status response comes from. And the shortcut done in most of the certificate world is they produce these huge revocation lists once a week. And so the question you're asking is, was this dud a week ago? Whereas the question you thought you were asking is this dud right here, right now? And it's those kinds of problems that the certificate folk just shovel under the carpet.
Yes. So I'm going to take away. It's a good comment you've made, and so what I'm hearing is there's an additional revocation aspect here that isn't in depth yet on these slides, but it's something to add into the things we need to deal with.
Yes, agreed. Thank you.
Lorenzo?
Lorenzo Colidi. I mean, I think just wanted to say Android is one of the implementations that doesn't currently do DDR, but we are working on it, and I think we're going to support both name-based and opportunistic. Of course, you know, if we don't have the right IP addresses on the CPEs, then I don't think that'll work. That said, I mean, a lot of CPEs do have public IP space, and it doesn't seem impossible to assign them proper DNS names if you're the operator, right? For v4, yeah, there's no way, but for an IPv6, a lot of CPEs do have IPv6, particularly new ones. So that could be a way of saying, because like one of the issues in the slide is like, well, if we don't have a public IP address, then it doesn't work. It's like, well, yeah, that's IPv4. Well, don't use IPv4, or don't use IPv4 only. I mean, like, don't use IPv4 only is kind of industry best practice at this point, right? So, you know, many networks do this.
Yes, if you have a public IP address, DDR in opportunistic would work, but not the authenticated one.
Welcome back,
But
Ben.
realistically, am I going to trust some random CPE? It's buggy. It's not up to date. It's probably owned. I mean, encryption
No,
is...
no. I mean, just like any endpoint, right? I mean, there are content providers who are good and bad, just like CPEs, which are good and bad, right? I mean, you can't, just because there's some brick CPEs, you can't say all the managed CPEs are bad, right? We have been deploying this. We have been constantly updating the firmware and software to keep up with the latest crypto and software updates. So we are doing as much as any enterprise class security, right? I mean, it's a network managed service by the end of the day, right?
Okay.
Go ahead, Ben.
Hey, so I'm here to nitpick Lorenzo. So DDR has like a lot of modes, at least 3 in my view. There is name-based DDR, where you say, like, hey, operating system, my DNS server is dns.google. And the operating system, to learn about what is up with dns.google, resolves a DNS record for _DNS.dns.google. And that tells it information about that thing. And then there are the IP address modes. And in those modes, there's a further subdivision between authenticated and opportunistic modes. And for any IP address, you always are within your rights to do opportunistic, in which case it doesn't matter if you're talking to a completely broken, insecure DNS server that is being operated by the adversary. You opportunistically encrypt to it. You haven't made anything worse. You haven't made you haven't made it much better. And there's the authenticated encryption modes, which only apply if the server has a public IP address, and if the server was configured to you by a public IP address, so however your configuration worked, that's what you got. Then DDR becomes a little more powerful. You have some redirection capabilities, but we're talking here about the opportunistic mode. So whether or not the IP address is in the public space, you can safely just start encrypting to it if it says that that's allowed.
Ralph?
Yeah, and just observation. I mean, even if CPs have v6, they usually give you link local as the resolver address and not the actual public address. So again, for the DDR opportunistic, it really doesn't matter what Ben said.
Okay, well, that's the cue. So does everybody now feel comfortable we have framed the problem? If the answer is yes, we have no more questions to ask. If you have questions, now's the time to ask. We've got about 14 minutes left in this morning session. I'm going to point out that Chris Box has looked over me a couple times like, So I think Chris is wondering, what have I agreed to? Or he's trying to make dinner reservations and wondering what he agreed to. Sorry for Chris for calling you out. So if we are done with this thing, I'm going to say maybe we call the session early. If we frame the problem, we will meet again this afternoon at 3:30. And what room are we into? It's in the slide somewhere. It's in this. Oh, and Ben just joined the queue. So Ben, one second. We'll give you a chance to talk. So the next session will pick up at 3:30 this afternoon in room P2, where we will start off with Tommy Jensen is going to talk to his draft, and we're going to take comments, and then we're going to go back to this thing, but probably go more into the, well, what do you want to do about it mode, but with the expectation. We are not expecting that we're all going to walk out of here at the end of today going, well, that problem's solved. This is a hard problem. We're talking about how to solve it and approaches to it. So don't think we're going to solve it this afternoon, but we are going to have some great conversations. And now, Ben, comments, please.
Hi. Since there's spare time, I will burn it. So I just want
you have 11 minutes.
I just want to say something that I think we're circling around in the chat, which is, in my view, this question of connecting to your DNS server on your local network securely or more securely, whatever that means, is exactly the same problem as connecting to your printer more securely. It's exactly the same problem as connecting to your local file server or your TV or whatever. And those are interesting problems. Those are problems that I think the IETF should try to solve, but I don't think that they are problems that ADD should try to solve on its own. I think what we can do is take our deep investigation and experience with this particular version of the problem and take that up to some broader, maybe new working group at the IETF, and make sure that we come up with a broader solution that addresses this use case among all the others. Thanks.
Yeah, Mr. Nygren. Oh, Eric, wrong one, Mr. Vink.
Yeah, both as Eric Vink, both as an individual contributor, as an AD, I start to see that this problem is much bigger than ADD. So food for thought for this afternoon.
I just heard that we're done here and that the ISG is going to solve all the problems for the rest of us. No.
No, the trust will do. Trust you, man.
I was trying to do an optimistic problem encryption or optimistic upgrade. All right. So we'll see you all again at the Q said it,
3:30.
at 3:30 this afternoon in room P2. See you then. Have a good lunch.
Bye. Everyone.
Thank you very much, Stuart. It was really good.
Thanks.
You didn't want to come out. This thing didn't want to pop up. Sorry for calling you out, man.